Hi. Okay, let's do the following graph on velocity versus time. So the movement of an object is graphed in the following picture. Okay, at the initial time, time equals 0 seconds, the position is 0, 2. So we're gonna answer 3 questions. Number 1, which is the acceleration for each interval. Okay, so remember, the acceleration on a velocity time graph will be the slope, right? Okay, so this will be the first interval, the second interval, and the third interval, okay? So for number 1, acceleration is gonna be final velocity minus initial velocity dividing by the final time and the initial time, right? So final time, the final time will be, oh, sorry, the final velocity will be 12. And the initial velocity will be 0. This is dividing by the final time, 3, the initial time, 0. That will be 4 meters by second squared. Okay? Remember, the acceleration of the object will be the slope on a velocity time graph. Units will be meters by the square second. Okay? So let's do the second interval. The acceleration will be final velocity, initial velocity, final time, initial time. Final velocity, 12. Initial velocity, 12. Final time, 6. Initial time, 3. Oh, yeah, that will be 0. Look at this. 0 on acceleration doesn't mean that the object is not moving. Okay, no, no, no. Look at the graph. The graph will tell you about the characteristic, the movements characteristic. Actually, between 3 and 6, the object is moving with a constant velocity, and that's it, 12 meters by second. Okay, so this is very important. The acceleration will be 0, but the object is moving at constant velocity and a constant velocity of 12 meters by second. Okay, yeah, very good. And the third interval will be acceleration final, initial, final, initial. So will be 0 minus 12, yeah, 0 minus 12 dividing by 8 minus 6. That will give you minus 12 dividing by 2. That will be minus 6 meters by the square seconds. Remember that graph, if you are reading the graph, you read from left to right. So this is the initial point. This is the final point. Remember that, please. That's the reason why and the final velocity is 0 and the initial velocity is 12. Final time 8, initial time 6. Okay, so very good. Okay, the meaning or the interpretation about the acceleration of each interval, yeah, it means that in the first interval, the object accelerates. But on third interval, a negative means that the object is slowing down. Okay, excellent. That or these are the information about the physical meaning on the number of the slope or the acceleration for each interval, right? Okay, so that will be question number one. Question number two will be the total distance. And remember, this is very important. The total distance will be the area under the lines, okay, under the lines. So that means that, for example, here, this area, yeah, I'm choosing the color yellow, yeah. This entire area over here, 0 to 3, 3 to 6, and 6 to 8, all the entire area under the lines, under the straight lines, will be the total distance, the distance for each interval. So let's calculate this. Let me see. Yeah, okay, so for the first interval, okay, for the first interval, the distance that the object does is, okay, you have to find the area of this triangle. So base 3, height 12 divided by 2. Okay, that will be 18 meters. So the object for the first 3 seconds will move 18 meters. Then the distance on the second interval will be, that's a rectangle, right? So base 3, yeah, 3, because the difference between 3 and 6 is 3. Height will be 12, and that's it. It's not divided by 2 because it's a rectangle. That will be 36 meters on the second interval. And the distance on the third interval will be 2, that is the base, 12, the height, and divided by 2 will be 12 meters. So the total distance, will be 18 plus 12, that will be 30, plus 36, 66 meters. Yeah, that's the total distance that the object moves. Okay, excellent. And what about the third question? Position at time equal 2 seconds, 5 seconds, and 7 seconds. Okay, so for that, let me see. For that, okay, so for the first interval, position, the final position for time equal 2 seconds will be, okay, remember, this is the equation. Initial position plus the initial velocity by time plus 0.5 by deceleration by the time and the square time, yeah, square time. And that's it, that's the formula. Okay, so look at this. If I am on the first interval, yeah, okay, the initial position for the first interval, the problem here on the announcement is the information about the initial position. Yeah, the initial position will be 0. If you look the graph, you can find the initial velocity. Yeah, oh yeah, the initial velocity is 0. Yeah. Time is going to be 2. Yeah, okay. 1 divided by 2 by the acceleration. Okay, look at this, the acceleration of the first interval, right? That is 4. And time is 4, and yeah, the exponent is number 2. Sorry, time 2, and the exponent will be 2. Okay, so it's a square 2. Okay, so do the calculation. That will be 8 meters. Meters will be the unit on the position. So the final position is 8 meters. So of course, that will be the position of the object 2 seconds after the movement started. Yeah. Okay. So excellent. Now calculate the position of the object when time is equal to 5. Okay, so 5 seconds is in the second interval. So yeah, again, the same formula, right? Now we are in the second interval because time equal 5 seconds is here on the second interval. So initial position plus velocity, but initial velocity by time plus 1 divided by 2, deceleration and time. Excellent. So this is the first mistake. Oh yeah, 8. Okay, 8 will be the initial position from the second interval. No, it's incorrect. Okay, why? Okay, look at this. You have to read the graph. Okay, the object starts moving here on 0 seconds. So accelerates and arrives to 3 seconds. The velocity will be 12, right? Okay. Then after the 3 seconds, now we are in the second interval, right? Okay, number 2. So this point over here is very important because it's the continuation between the first and the second interval. That's the union. So if this point is the union, use logic, the final position of the first interval will be the initial position for the second one. Oh yeah. So before we do the final position as 5 seconds, first we're gonna find the final position for 3 seconds. Why 3 seconds? The problem doesn't say about calculate the position at 3 seconds, but I need it. Okay, the final position at 3 seconds will be the initial position for the final position at 5 seconds. So here, yes, I calculate the final position for 3 seconds. Okay, I'm writing here a 0, yeah, because 0, I am actually an extreme on the first interval. So the initial position is 0, 2. plus 0, because 0 is the initial velocity. Time will be 3 plus 1 divided by 2. Deceleration is 4, and the time is 3, and the exponent will be 2. Okay, so I am finding the final position at 3 seconds, because 3 seconds is the final time on the first interval. And this number will give us 9 by 4. 9 by 4 will be 36, and divided by 2, 18. Yeah, and it's logic. Come on. Come on, guys. It's logic. The distance of the first interval was 18. Oh, yeah. Yeah, the final position at 3 seconds is going to be 18 too. Oh, yeah. So the initial position for the second interval will be 18. Yeah, because this value is the final position of the first interval at 3 seconds. So this will be the initial position for the second interval. Look at this, the initial velocity. Oh yeah, the initial velocity for the second interval will be 12. Time, oh yeah, it's 5 seconds. The acceleration, the second interval, oh yeah, it's 0. And 5 with the exponent of number 2. Okay, so please use the calculator. 18 plus 12 by 5 is going to be 78. 78 meters. 78 meters. Okay, so nice. That will be the position. And remember, the position is the position of the object from the region is not the same as distance. So take it easy with that. Okay, it's not the same as distance. Distance is the length of the trajectory. Position is a point on space, which is from let me see. Yeah, it's for a distance between this point and the origin, but it's not the distance that the object is moving. Okay, so take care with that. Okay, and the final position for 7, okay, for the third interval, the final position and time of 7. Okay, oh, I will have here the same problem that the last interval. Yeah, the final position to study the third interval is when you study the final position at 6 seconds on the second interval. Oh yeah, I understand. So yeah, if you calculate the final position for 6 seconds on the second interval, yeah, the second interval will be the interval before the third one, right? Okay, so this will mean that the initial position on the second interval was 18, yeah, 18 plus the initial velocity on the second interval will be 12. Time will be 6, 1.5. By deceleration here is 0, and time will be 6 square. Okay. Excellent. So yeah, use the calculator. 18 by plus 12 by 6, 90. Okay, 90 meters. 90 meters will be the initial position for the third interval. And 90 meters will be the final position for the second interval. So this is the union between second and third interval. Oh, yeah, so the initial position for seven is here. Yeah, between 6 and 8. The initial position will be the position of the object at 6 seconds. Oh, yeah, it's 90. 90. Initial velocity of the third interval, 12. Time, 7. Yeah, 1 divided by 2. Acceleration. Oh, yeah, remember, deceleration is going to be -6. -6 because it's deceleration on the third interval. And time, oh yeah, 7. And the exponent, number 2. Okay, so 90 plus 12 by 7 plus 1 divided by 2 by -6 by 7 on square exponent. So, oh yeah, that's going to be 27. Okay, so look at this. You can interpretate the final position for different times and try to guess where is the object and what it's doing. So for example, in the first interval, the position at 2 seconds, it's 8 meters. Yeah, okay, very good. Oh yeah, the final position on 3 seconds for the first interval is 18 meters. Yeah, good. Okay, so continue. Oh yeah, the final position for 5 seconds is 78. Yeah, I am in the second interval. Okay. The final position for 6 seconds will be 90 meters. Okay, yeah, excellent. Okay, so position is increasing with time. 8, 18, 17, 90. Yeah, okay, okay. But hey, wait a minute. What happened at 7 seconds? Oh, the position is 27. What happened here? Maybe it's wrong. No, it's not wrong. Okay, the final position at 7 seconds is going to be 27 meters. Yeah. And what about the interpretation of physics about this number? Yeah, the interpretation is very easy. In some point between 6 and 7, I don't know, can be 6.2 or 6.5 or 6.8, whatever time between 6 and 7, the object turn around and is going back to the origin. Okay, and in 7 seconds the position will be 27 meters. Yeah, it's 27 meters from the origin, the final position of the body. Yeah, and if I calculate for example, the final position 8 seconds, okay, 8 seconds. So the final position will be -6. Oh, look at this. If I calculate the final position for time equal 8 will be 90 plus 12 by 8 plus 1 divided by 2 minus 6 by 8 square exponent, that will be -6. What does it mean? Okay, -6 is telling us that the final position when the movement has 8 seconds is going to be 6 meters to the opposite direction from which the object starts moving. So imagine, because I didn't write that. Imagine at the beginning of this exercise, I wrote here. Okay, the object starts moving to the north. Okay, so, here is the interpretation on the -6. So the final position when time is 8 seconds will be 6 meters to south. Okay, at 8 seconds, the object is at south. Yeah, it starts moving to the north. Now at 8 seconds later, the object is going to be on south. Oh, well, remember, this graph, velocity time graph, will not tell you the distance. Yeah, okay, you can calculate the distance, yeah? Okay, you can calculate the distance, yeah, only the calculation of the area under the straight line. Yeah, I know. But the graph will not tell you where exactly the object turn around and go back to the region. Yeah, the problem or the graph will not tell you that, because this is a graph, it's a velocity time graph. Okay, it's only show you the velocity for each time that the object is moving. No, where is it? Where is the object at different times? Remember that. Okay, so that's it. Thank you.